Welcome again. Here we go. So to start with today, you can see here that what we're going to do is ask you at the top of page 3 in your lab notebook to fill in that review table with your lab partner. Now we're a little behind on this, so what I'm going to ask you to do is, as soon as I'm done talking, come back onto page 3 and fill in that review. But what we're going to do is work to get through the rest of this, okay? So after this, we talk food chains. Now, food chains, many of you have done probably since you were in elementary school, everything else. The food chain, as we're doing this, you can read here, is the path of food from one organism to another. We're going to always start that or begin that with a producer, and we're going to always end it with a consumer. Producer, if you remember, is one that can make its own food. Consumer is one that has to eat others in order to gain that. This point here is one I want you to remember. The sun is the ultimate source of all energy. On our planet, every bit of energy, from the ability to move, think, talk, speak, in humans, in animals, everything comes from the sun. It's also the source of all heat for the planet. Every last bit of energy on our entire planet, including the energy from the gasoline in the car you drive, came from the sun. That sun came down, shone on the plants. The plants were able, many, many years ago, to be able to take that and change it into energy. The plants then died, but that energy was stored in different molecules so that when that plant, or even the animal that ate that plant, the dinosaur that ate that plant, died, that energy stayed stored in what we'd call a chemical bond in order to later be pulled up as oil, refined, changed. You go down to the gas station, you put it in your tank, and that energy that makes your car go every single day came from the sun. So on our planet, the sun is the source of all energy. Every bit of the food you eat, everything got its energy from the sun. So without the sun, we would have no energy on this planet. Here we can see a good food chain here. We start out with the grasshopper that's eaten by a frog. Frog gets eaten by the snake gets eaten by the hawk. And that's just a straight line. Now you'll notice the arrows here, and pay very close attention to the arrows. In this, it seems real simple because the arrows are all pointing up. But the arrows are showing where the energy is going every single step of the way. So we need to remember that as we do this, that the arrows always show where the energy is traveling to. If you put an arrow on one of your food chains that goes from the hawk to the snake, that snake better have eaten the hawk. Flow of energy through a food web is not very efficient. And as we talk about this, so what happens is, as we go up on the slide here, even to the food chain, you'll notice the snake does not get all of the energy that it ate from the frog. A lot of that, right, the frog's got energy in every cell in its body, but the snake doesn't get to capture all that. A lot of that is lost to heat. In this room right now, I'm sure that you're doing a very good job of losing energy through heat. Actually, it's probably hot enough that you're probably not losing an energy through heat. You're losing energy through sweat. But what happens here is, as we lose this, the heat is the energy that's there that's not burned as muscle energy. Inorganic nutrients are cycled. Energy is never cycled. So when we talk about inorganic nutrients, what we're doing is we're talking about water, we're talking about carbon dioxide, we're talking about all of these different things that are not organic, and they can always change form. If we follow hydrogen through, it's going to go from water into sugar into all of this, and it's always going to keep going, but it's the same hydrogen molecule that makes that. Energy, however, is never cycled. Energy is changed in forms, but once that energy is used, it's gone. Wrong button. Okay. Trophic levels. Now, if we talk trophic levels, understand that trophic levels refer to the organism's position in the food chain. So autotroph, remember we said, means self-food. Well, the trophic then for that would be that organism's position would be the very bottom, or as the autotroph, meaning self-food and can make its own food. Now, in your web packet here, it asks you to make a food chain. So due to just not having to change out a whole bunch of videos, what I'm going to ask at the end of this is that you go back and you fill out that part on part 3 where it asks you to do a food chain, and then it also asks you to do the food web. Okay, so if you'll fill it out, you can actually do it right now. We can label the trophic level each organism falls into. So the grass, where would the grass fall into in your food chain on page 3? Well, if we look right here, we can see that the grass, getting energy from this happy sun, is the producer. Right? So the grass is the producer. Along comes the grasshopper, it becomes the primary consumer, and you can see and follow here that the grasshopper then becomes the primary consumer. Okay? What happens when the mouse, and yes, mice will eat grasshoppers. So the mice, down here we've got a frog. Is there any difference in the mouse eating the grasshopper or the frog? No, each one of those becomes a secondary consumer as soon as they eat the primary consumer. You're all right. Imagine that, someone coming to the door and needing me. And squirrels. Okay, so once the mouse and the frog have eaten that, they again become the secondary consumer. We have the snake, which would fill the same position as this trash panda down here, the raccoon, right? And they would become tertiary consumers, and same thing with this hawk or this owl, whichever one you want to put in here, right? But once they eat more than the simple primary consumer, they have to become a tertiary or a top level consumer. And then again at the end we always have the decomposers. Okay, so here's a basic food chain. The basic food chain, remember, shows just one path of energy. We have the wheat to the mouse to the owl. Okay, here again we have, if we start here with our primary consumers, right, going to, producers or autotrophs, and then we go here to the primary consumers, to the secondary consumers, or in this case this may even be considered, because we're only one level up, it's probably secondary, but the cat could be tertiary if the cat was eating something different, or the mouse had eaten insects instead of the corn. And then we have our decomposer. Remember, these are the guys you want at the party. They are the fungi. Okay. Here again, just making sure you understand this concept. Producers, first order, second order, third order consumers. We've already done our own food chain. Okay. Now food webs become a little more complicated, because when we get a food web, we're going to add the complete set of interrelated food chains showing all relationships in a community. So as you have this, and you have this on your paper here, you want to fill that out in the middle of page 3. Now in a food web, we're showing all possible feeding outcomes. So if we look, we will always start, and this is great, but what I want you again to remember is that everything on this entire chart here got its energy from, turn and tell your partner where. And if your partner did not say the sun, if you will correct them gently and kindly and with decency. Great. Okay, so here we have plants. Now there's all sorts of different type of plants. Corn, wheat, grass, all sorts of different plants here. And in this food web, we're going to show all the different animals that will eat as primary consumers from the producers. Rabbits, squirrels, mice, seed-eating birds, herbivorous, That word is herbivorous insects. And as they're eating all of this and becoming primary consumers, well, how many different things do you think are going to eat rabbits? In this case, it's two, right? We have foxes and hawks and owls, so I guess technically three. And you'll notice that in this case, we have small snakes, so they're not going to get all the way to the rabbits. Squirrels are also going to get eaten by foxes and owls. The mice are going to get eaten by foxes, owls, and because they're small snakes, they will eat the mice. Seed-eating birds, foxes, hawks, and owls, snakes. Now, here's where it gets a little funny, is if we take these herbivorous insects, and now we take, and they're eaten by predaceous insects. Predaceous insects, the best example I can think of would be the praying mantis. It's going to come along, and it's going to simply eat other insects. It doesn't need to feed on the grasses or the plants. And even these predaceous insects are going to eat spiders, and vice versa. So at this point in time, at the second level of, or secondary consumers, they are preying on each other depending on the type. Along come insectivorous birds, right? These birds that are going to simply eat other insects, and they're going to be preyed on by foxes and owls and snakes. We get these toads that are going to come along and eat all sorts of different things. We have these snakes that are going to come along and eat different types of insects. So notice we left snakes very, very general here. We also left hawks and owls very, very general. But what happens is you can see that there's all sorts of different interrelated activity on this, and this is going to be a lot more accurate in a given community. Now, while this one here is very, very good, I'm hoping you're realizing that, or you're looking and you're being like, what about this? What about that? What about this animal, right? There's no coyotes on here. There's no anything, you know, whatever animal you're thinking. And that's true. And so in order to make a true food web, it would be huge. It would be complicated. So we try and keep it very, very thorough, but realizing that it's not going to be complete. Now, as your assignment for today, you are going to grab a piece of paper. And when I say piece of paper, I'm talking one of these great big white poster board papers or the butcher paper that we have. And you are going to work in groups of no more than 4. And for every member of your group, you have to have at least 4 things on your food web. So you're going to work in groups of 4. You can spread out around the room. You can see here we've got tables set up. Now this is early, but everything will be on your tables. You'll have markers. You'll have pencils. If you have 2 people in a group, you're going to have 8 items on your food web. If you have 4 people in a group, you're going to have 16 items. I don't care whether you do a real food web or an imaginary food web. You can do the Nintendo food web if you want. If you can show me what Donkey Kong's going to eat, you can do that. If you want to do the Disney food web, I'm great with that. As long as you can show me what the different animals are going to eat and make it. Now when we do the arrows on that food web, make sure that you are showing where the energy is going. So if you're going to do the African Plains one and you do a lion eating a zebra, that's great. Just make sure that the arrow is pointing from the zebra to the lion because that's where the energy is going. Hopefully that'll get you through and you'll spend the rest of the day doing that. Make sure you're thorough. Make sure that you have fun. Make sure you put your names on the paper so you can get credit for it. And enjoy.